Welcome to the physics class again today. In our last class, we were able to define for you the meaning of elasticity. I remind you that elasticity is a property of solid object, solid material, to ability to regain its size, its shape when force is applied on it. When force is applied on it, and then the force applied on it released, the object has the ability to regain its size and its shape, elasticity. And then there's a property. Then that material that undergoes elasticity is called elastic material. I gave examples. I used spiral spring, I used rubber band, and I used rubber, the elastic materials. Now, going to look at the Hooke's law. I said, according to Hooke's law, provided the elastic limit of an elastic material is not exceeded, the force or the load applied on an elastic material is directly proportional to the increase in length, which we call extension. See it now. This is the spiral spring, which is elastic material. Let's place it here and then apply. This is a 50-gram mass. 50-gram mass. First of all, we have to take the original length. The original length of this. The original length of this from the measurement here is 8 cm. 8 cm. That is the original length. Now, let us put it here now and apply force. Apply, this is now our load. Let's load it here now. When we apply it now, you see that there will be increase. If we measure it now, if I measure this from here to here, it's giving me 8.05 cm, which means that this load here extended this to 0.5 cm. This is the increase in length. This is the original length. This is the original length. L0. This is the new length now. So the increase in length now is going to be the new length minus the original length, which will give me 8.05 minus 80.00, which is giving me now 0.05 cm. This is what we call the increase in length, what we call the extension. The extension. Now, let me increase the load again by adding extra 50 cm mass. 50 cm mass. This load I added here now has increased the length. The length now here is 9.10 cm. We can find also the increase in length by subtracting the original length from the new length. So according to Hooke's law, there will always be increase in length on an elastic material whenever load is added. And according to him, this increase in length is proportional to the load added. So it's going to be a straight line graph like this. A straight line graph, when we plot the graph of extension against the load, we will get a straight line graph from the origin, which means that as the load increases, the extension also increases. It's what we call direct proportion. I will state the law again for you to understand what I mean. What I said is that according to Hooke's law, provided the elastic limit of an elastic material is not exceeded, the applied force on elastic material is proportional to the extension. Now, we are going to look at what we call this elastic limit. From here, from 0 to P, 0 to P is called proportional limit. From 0 to P is called proportional limit, which means that this graph from here to here, the load and the extension are proportional. Now, but at this point, this particular point called E is what we refer to elastic limit. The elastic limit simply means that particular point that if exceeded, the material undergoing extension will not return to its original shape, to its original size. Out of elastic limit. So if we exceed this place now, the extension and the load will not be proportional again, because the material has undergone deformation. It has been deformed. Now, from this place here is called yield point. E is what I call elastic limit. I want to define the Y, which we call yield point. The yield point. What is the yield point? The yield point is the point on an elastic material undergoing stretching, whereby that material yields to the elasticity. Means that at this point now, the extension produced will not be proportional to the load applied, because it has lost its elasticity. The extension produced is going to be bigger than the force applied. Any small force applied is going to generate a very high extension. At this particular point called B is called the breaking point. At the breaking point, if there is any further extension, that material will start breaking down. It start cutting, start breaking. At this point, we look at what we call from 0 to P is called proportional limit. Then from 0 to E is called elasticity limit. Elasticity limit, a limit that is here, this particular place, any force applied here, from here upwards, the material will not return to its original size. Then from 0 to point here, let's call here F. 0 to F. From 0 to F is called plasticity. Plasticity region. Plasticity. This is the point where if you extend, you have passed elastic limits and you apply force again, it will reach plastic point. It becomes like plastic. Then here is called the breaking point. Thank you. In the next class, we are going to have calculations on the Hooke's law. Make sure you share, you follow, you like, and then drop your comment on the comment section.